and welcome. I'm very excited because we are going to be starting differential equations proper today. So let us take a look at the definition of a differential equation. A differential equation is a relationship between the dependent variable y, independent variable x, and one or more derivatives of y with respect to x. So in this case, we are considering a function where y is a function of x. So you can see y is the dependent variable, x is the independent variable, and dy dx as the derivative, or this is sometimes called the differential coefficient of y with respect to x. So the differential equation is an equation that contains one or more differential coefficient. This is called the differential coefficient. These are the examples of differential equation. You can see dy dx is 3x is equal to 3x squared. X squared dy dx is equal to y sine x. Dy dx is equal to 1 plus x squared divided by 1 minus y squared. Xy the 2y dx squared plus y dy dx plus e to the 3x is equal to 0. These are all forms of differential equations. Now, I know some of you must be thinking, oh, so does that mean that when I take the derivative of a function, I am creating a differential equation? That is right. Anytime you take the derivative of a function, you are indirectly creating a differential equations. And you've come across differential equations in other disciplines, let's say physics, because you can remember that velocity is given as ds dt, which is equals to the velocity v. You can see this is a differential coefficient. Now, a differential equation in some textbooks is defined as an equation that contains one or more differential coefficients. So, because in some cases the dependent variable is sometimes missing, and in some cases the independent variable is sometimes missing. So you can see this differential equation has a differential coefficient of s with respect to t, which gives us the velocity. This is an equation in physics which relates the distance and the velocity together. Okay, so before we go any further, I would like to give you a comprehensive knowledge about differential equation and how it differs from the other constant equation you've been doing so far. So what differentiates a differential equation and the other equations to know? Because a differential equation is of this form. Let's say dy dx is equals to 3x squared. This is a differential equation. Now, up until now, you've done equations like x plus 2 is equal to 0. These are called constant equations because the answer you are looking for in this equation is a constant. If I solve this now, I'll get that x is equals to -2. You can see -2 is a constant. So the answers you seek in constant equations are constant value than numbers. You seek for numbers. But in differential equation, what you are trying to find, the solution to a differential equation is always a function. It's always a function. So what you try to find in a differential equation, or the solution of a differential equation, they are all functions or families of functions. Let us solve this for example. If you take dx to this side, you have that dy is equals to 3x squared dx. If I integrate both sides, this takes out this, so that you have y is equals to the integral of 3x squared dx. Let us integrate this. So y is equals to 3 can be brought outside of the integral sign, so this is 3. The integral of x squared is x to the 2 plus 1 divided by 2 plus 1, and don't forget your constant of integration plus c. So y is equals to 3x, 2 plus 1 is 3, you divide it by 3 plus c. This means that y is equals to x cubed plus c. This is the solution of a differential. This is the solution to this problem, and you can see it is a function y relating the dependent variable y, the independent variable x, and some constant. This is to tell you that this c is called an arbitrary constant. C is called an arbitrary It is called an arbitrarily constant because it can assume any value, give it, because y is equal to x cubed plus c. If c was 5 here, if I take the derivative, I will get back this. This c disappears because it is a constant. The derivative of the constant is 0, so it doesn't matter. So you can see this is a family of functions. So you can have y is equal to x cubed plus 1, y is equal to x cubed plus 2, and they will all satisfy this equation. So the solution to a differential equation is a function. The solution to a constant equation is just a constant. You are looking for a number. In differential equation, you are looking for a function.